simulate how slow it is, are we going to have a linked list and a singleton?
How slow what is?
The RAM is compared to the registers.
Oh, I get what you're saying. We could put it in like its own thread and tell the thread to sleep. So, but I think maybe we won't do that.
Is stored as a txt file in the root directory.
Even then, we probably wouldn't notice. Just doing a single file IO read wouldn't be long enough for us to notice. Okay, so as of right now, if I go ahead and run this guy, oh, did I not hit play? Thought I hit play. Oh. All right, so I'm not very good at clicking this mouse. I'm very good at zooming by accident, though, like when you're on a web page and you get to zoom in and zoom out. I do that by accident all the time. It's terrible. All right, so if I go into my registers and I just change these to a couple of values, 2 and 3. And then I save, and then I execute. The idea is it should now be a 5 and a 0, and there it is. Okay, so it's reading from my registers, doing the math. All right, so what we were supposed to do for our homework is to get add I, sub I, all working. All right, so let's go ahead and do the add I first, since that guy is the one that's going to be the closest to what we just did. The difference between add and add I is that rather than having our second register input, we actually have an immediate value. Okay, so our input 1 is actually an immediate. So here's our well, this is our destination register. This is our input register. So we have the input names. Now for add I, input names at bucket 1, where are we building the input names? Up here. So this is where we're splitting this instruction up, right? So we have our magic trick. We do all the parsing. We ultimately get our destination input names. So for our bucket 2 of input names, we would actually have the immediate value, right? So rather than having a register for that one, we'd have our immediate value. So I'll just steal these 4 lines and then we'll doctor them a little bit. So we're doing add I first. All right, so we'll get our destination name because it still has a destination. We'll go ahead and our input 2 register is bucket 0. That still exists, right? Still have a register for our second input, which is actually the first one in the order. The reason why we're flipping them around is mainly to show how subtract works, right? It's the second from the first. All right, then this guy right here is not going to be a register. Instead, this guy here is going to be a number. So I'm just going to steal this string because my input names is actually a array of strings, right? So I'm going to be int immediate value is equal to integer.parseInt of that string. All right, then our destination register will be input 2 register plus our immediate value. Like that. All right, so let's run this guy. All right, so I'm going to change this to a 20 here. We'll change this to an add I. I'll go ahead and update my register X1. We'll make that guy a 5. Save. So I should be putting into X0 a 5 plus a 20, giving me a 25. And there's my 25. All right, so that's add immediate. That makes sense? All right, so now when we do a subtract, let me actually just update my code in here. So if I update the default value in here and I say sub x0, x1, x2, what's the order that actually happens here? Am I subtracting x2 from x1 or am I subtracting x1 from x2? Okay, so this is equivalent to saying x0 is equal to x1 minus x2. Yeah, good. All right, so that means that this is the value, well, this is the value we subtract from this value, storing the result here. So we'll go into the code here, which is in instruction, right? We'll steal these guys up here. And we could probably do this with less duplication of code, but let's just roll with it. So we have our destination name. We have our input bucket 0, input bucket 1. So that's our input 2 register, input 1 register. And what we're going to store is input 2 register minus input 1 register, storing that in the result. All right, but we need to make sure that we do the registers in the right order. We don't treat the guy as the wrong guy. Okay. Run that. It's still running, I think, isn't it? Did I not save this screen? This screen. Oh, well, I changed it. There we go. All right, so we'll put in x1 a 5. We'll put in x2 a 3. We'll save. Execute. Go to registers. Oh. And there's my 2. 5 minus 3 is 2. Okay. But now, what if I change this to a 7? Save this. Execute this again. Oh, why does it make this thing go away? I really should just not have this in the background because it's going to trick me all day clicking on my interface, wondering why buttons aren't working. All right, registers. Now we have a -2. Now, to store a -2, what actually has to happen? Realistically. Yeah, encode it in 2's complement, right? Right now, we're just storing decimal values, so like everything's fine, right? It just works, right? But the reality is the way these registers would actually get represented is with the binary representation of these values, correct? So that means if we try to put a negative number in there, we would have to store it as its 2's complement equivalent. All right, so we'll come back to that here in a second. You didn't have to do that for this assignment, but you know, if we're fast forwarding and thinking, well, how do registers actually store values? We don't get the nice human-friendly format like this. We get the computer-friendly binary format. All right, so last. I'm lost. Structure. All right, I'm going to go ahead and steal my add I code. So that gets my immediate value. And we'll write sub I. Just like that. Input to register value minus immediate value. All right, so we'll do a sub I here. And we'll say x1 minus 10, let's say. We'll click on our registers. We'll put a 34 in x1. We'll save it. Then I'll go ahead and click execute here. So now x0 should have a 34 minus a 10, so a 24 in it. There's my 24. Make sense? All right, so that was the homework. All right, so not too bad. All right, so now we got to go back and think about how are these things actually stored. Now, what might be nice is, see, these are editable. What might be nice is for me to be able to click on these registers and maybe have it show me a screen that has the decimal value and the equivalent binary value. That might be kind of fun, right? One downside to that, though, I think, is this is my register screen. That's a text view. Can I respond to a click on a text view? I don't think so. Oh, the answer is maybe. That would be really nice if I can, so I don't have to go put buttons in there. Well, there's actually other ways to do it, but I don't want to do touch interfaces. But let's just see if that works. So I'm going to go to my register screen, and I'm going to just throw a function in here that will respond to a button click thing. So I'll just do public void register name TF clicked, something like that. Pressed, let's do pressed. And this guy will take a view V as a parameter. And then for right now, let's just prove that it works by giving ourselves the text view version of V. That's the guy who called this. And then we'll just say v.setText to woot. All right, and we'll go ahead and hook up that text view to this guy so that hopefully we can click a text view and it will grab the text view that called this guy and change his text to woot. I don't know if I've ever actually tried having a text view be clickable, but we're going to hope that this works. So there's X0. Here's on click. There's my register name TF pressed, so it at least lets me associate a on click with that. And that's just for X0. So let's test this guy. So the hope is I can click on X0 in my interface and it will change its text to woot. Woot! All right, so why is nobody else clapping? That's a pity clap. All right, so we're going to go ahead and give ourselves another screen for exploring the value of a register. Okay, because we already know as human beings, we kind of like looking at it from a decimal perspective, right? But we know also under the hood that the way our architecture works is it stores it in binary. So we want to prove that we can actually store it in binary, then give ourselves a decimal representation. And if you remember correctly, we actually wrote a whole bunch of these things for doing this, binary value and things like that. All right, so I'm going to give myself another screen that's going to allow me to show the current value of a register. All right, we can have something pop up on the screen, but let's just keep it simple and take it to another screen since we're not building a fancy thing. All right, so I'm going to create a new activity, empty activity. And we're going to call this guy register detail. We naming them activity. Let's just call it register detail screen. All right. And we'll leave all the other stuff alone. Hit finish. All right, so we have this guy, and here's my register detail screen design. I'll go ahead and give myself my vertical linear layout in here. We'll throw a text view inside of that. We're going to give ourselves access to this guy because we want to set what register we're showing the detail for. So this is going to say, like, I'll just default it to like X0 register detail. Actually, I'm sorry. This is going to be register name TF. That's the ID for it. The text will be, I'll just put a placeholder X0 register detail. All right, then let's give it a little bit bigger font size. So make it 30. We will go ahead and center horizontally to get it moved to the center. All right, then we'll hook this guy up, but let's just get this screen showing up first, making sure all our stuff is working. So this will give us some practice with singletons again. All right, so we'll have a X0 register detail. Actually, we might not need to use a singleton for this, but whatever. All right, so go into my code, give myself access to register name TF. Here's my register detail screen. So we're going to have a private text view. Is it text? Yeah, it's text view. Why did I call it TF? Did I call it text view or text TV or TF? TF. It's just bad form. Yeah, that's a UI text field is iOS. What are you going to do? All right, so now we're back here. So we're going to have a text view. What do I call it? Register name TV. All right, we'll go ahead and hook that dude up. This dot register name TV is equal to the text view version of this dot find view by ID. Come on, catch up. R dot ID dot register name TV. Okay. So we'll just leave it like that for a second. Let's go back to the previous screen and have that label actually launch this screen for us. So we'll create an intent for it so we can have that dude set up. So that is our register screen, register name TF pressed. I'm gonna leave the text, I called it TF there too. Bad form. All right, so we'll leave that there for now, but I'm gonna go ahead and create an intent to launch that next screen. So I'll say intent I is equal to new intent. And this guy is going to be coming from the current context, which is this. And we're going to be going to register detail screen dot class. All right, so we're going to intend to launch that screen, and then we'll use the current activity to go ahead and launch that screen. So this dot, what is it? launch activity, start activity, I. All right, we'll just make sure it gets us over to that new screen so we have all our stuff hooked up. Thought I hit play. All right, so I'll click registers. I'll click on my X0. Takes me over there. Everything's good. All right, so now what we want to do is we want to have the this X0 here. We wanted to say whatever register, the name of the register we actually clicked on. Right now, I only actually have the on-click set up for X0. And I want to do it for X1, X2, X3, X4, blah, 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 blah. All of these. All right. So does that mean I go in and do I write 31 functions and hook different functions up to each one? We come in here, all of these text views actually have the register name in them, don't they? So can't I just ask whatever text view called this, string register name is equal to tv.getText.toString? So that'll be the register name. And then I can send the register name over to the other screen. Now, I can do this through a singleton if I want. I can set a global variable and then access that global variable over there. In fact, since we already have a singleton, let's just do that real quick, but I'm going to argue it's the wrong way of doing it. All right, let's write it that way first. All right, so I already have a singleton. Is that AR map? Yeah, this guy. So I'm just going to create another variable here in AR map, public static, let's call this guy detail register name. And this guy will start off at, this is a string. All right, he'll start off as the empty string. And then what we'll go ahead and do is we'll go ahead and set that variable to the name of the register that was clicked. Oh, it's on the screen. So armap.detail register name is equal to the register name we just read in. Then we'll start our other activity. Over here on that other activity, we'll go ahead and set the text, this dot register name TV dot set text equal to armap dot detail register name. Just passing that across. And now we'll remove that extra register detail thing, so we'll see it actually change. All right, so we'll run this real quick, and we'll see that it works. So there's my X0. Okay. Similarly, if I just go ahead and set up my on-click on the second one, just so we have two different buttons. So here's my X1 here. Here is his on-click. Register name. Didn't I change it to TV? It keeps hacking me. There we go. Oh, maybe I did leave it as TF. Doesn't matter. I'm not going to change it now. Yep, I left it as TF. Okay. So now that second guy, X1, also will call that same function. So now I should be able to click either one of those. And it will take me over to the next screen, passing the name of that register. All right, so this guy takes me there and gives me an X1. This guy takes me there and gives me an x0. All right, so why is this a bad way of passing information to this other screen? Not that it didn't work, we see it working, but why might this be a poor use of a singleton? This kind of goes back to something we said last class, where this is probably one of the larger projects most of you have worked with, right? Okay, so we got a lot of moving pieces now, right? So what are we going to say?
Well, why use a singleton when we have functionality that can allow us to just take it and immediately pass it to the next activity without having to store it in?
Well, that's easy because it's convenient. Singletons were simple, right? I mean, that was 2 lines of code. Saved. Oh man, singletons are so easy to abuse. Right? It's trivial. Just use it. Go ahead.
Well, one reason the bigger your program gets, the more messy your singletons can often get, and then it gets confusing and hard to debug.
So we want to be good stewards of our singletons, right? So while it might be convenient to just throw everything under the sun in there that we might need to share between 2 screens, we probably want to have some sort of rule of thumb. Maybe we say that if you need something, if we want to err towards the convenience side, maybe we say that if you need something on more than 1 screen, you need something to be shared across more than 1 screen, then we're going to say it's okay to use the singleton. You could even maybe make a little, if you want to be more on the neutral side, you can make the argument saying, well, if you need to share something across more than 2 screens, definitely put it in the singleton. That's appropriate. That's an appropriate use of it. But if we only need to share something to 1 screen, we just need to get something from screen A to screen B, and no other screens need that piece of information, it would be in our best interest to go ahead and use the internal mechanism for passing information between screens rather than using a singleton, because as she pointed out, our singletons will start getting very messy very quickly. That makes sense? Okay. It's not that it's wrong, it's that she pointed out your code's going to get very difficult to debug. And then all of a sudden you get these really scary looking singletons, because you could make the argument like, well, maybe if I have different singletons for different groups of screens. Well, you can certainly do that. There's arguments to be made for not having just a single singleton. That's kind of the name of it, but single singleton in an app. You could have multiple singletons that kind of pertain to relationships with different screens in your app. But assuming you want to be super convenient and just have 1 big bucket that you just throw anything that needs to be shared into, what you end up starting to do is if you have a really big app with a bunch of screens and things like that, you start naming your variables like something very specific to like the screen you're sharing it between, like register screen underscore register name detail number 5, just to kind of separate these things. And before you know it, you have a mess. All right, so we're going to say since only that register detail screen actually needs to have the name of the register we clicked, we're going to go ahead and remove this from our singleton so we don't further clog it with information. We will go into, now let me actually put this back real quick and connect this to your software engineering class. So another thing that happens in here is now that those 2 screens are reliant on this singleton, what's that called? Starts with a C. Coupling. Yeah. So now that these 2 separate screens both rely on this singleton to share information between the 2 of them, now the screens might be, the detail screen, you can't get to that detail screen except from the register screen. So already you have a connection between those 2 screens. But now because we've chosen to use a singleton, we've brought in a third component. So now both of those screens are reliant on that singleton to make themselves work. Okay. Now you can make the argument that, well, the register screen was already reliant on that singleton because that's how we're saving our register information and stuff like that. But the register detail screen was not. So by making it dependent on that singleton, we're now creating a scenario called coupling, which isn't innately horrible, but the general rule should be we want to minimize coupling the best we can. Something like that. Okay, so I'll go ahead and remove detail register name from my singleton, and we'll instead pass that through the intent. So we'll go into our register screen, and I'll just steal that name. There's a pretty good name for that. So we create our intent, but before we start the activity, we're going to say, is it put extra? We're going to put extra, and we're going to name this guy detail register name, and the value will be register name. Okay, so I'm going to add in extra to my intent, giving it this name value pair. Then I'll go ahead and start the activity. Once I have that, I can come to the register detail screen, and instead of getting the name from AR map, I'll get the name from this dot get intent dot get, what is it, string extra, and this guy was called that. So I'll set the text to, I'll go ahead and retrieve the intent that was used to get to this guy. I'll ask him for one of his string extras. Which extra? The one named detail register name. And this will boil down to the string that was passed along through the intent rather than using the singleton. And we'll see that we get the same behavior. So there's our x1. Here's our x0. Make sense? So now we have the same behavior across these guys. All right, so questions about the singleton versus the put extra thing for sharing stuff between screens. Make sense why one might be preferable to the other one in certain circumstances? All right, so we're going to set up our other onClicks. That's on this screen. See, I don't think you can do it on more than one of them at once. Can you? Oh, you can. It's going to be handy. So I'm going to select a whole bunch. Can I select across multiple containers? That looks like maybe not, so I got to do a whole row at a time.
I'm sure it's actually being applied to all of them.
Well, I'm sure it is. I'm still waiting to make my first bug. Here, let's check X8 there. Doesn't it move it up top if I use it? Oh, there it is. Yeah, it did it. I'm holding down the control key to select a bunch of them at once.
If you use shift and click the first one, select all of them.
I'm going to doubt it, but we can try it. That makes you feel better. Nope, shift just worked the same as control.
Okay.
And finally, X30. All right, so now we'll exhaustively test all of them by just clicking 3 or 4 of them. It's the best way to test. Then upload and release. Did I click? I'm bad at clicking today, it seems like. All right, so we'll click X22. There's my X22, X30, X14. All right, seems to work for every single one of them. no, fully tested every single one of them. All right, so now that we have that working, we want to show the current value of that register. Now we'll start off by just proving we can get the value over there, just seeing the connection, because we're going to go ahead and get the register that has a particular value, right? Now remember, we have a register object here. And what does a register object hold? It has a human readable name. It has a decimal register number. That's the 5-bit number. And then it also has an integer value. All right. Now, if you remember correctly from AR map, we've given ourselves the ability to look up a register name, a register given its name. So find register with name. And on our detail screen, we happen to have the name of a register. Woot. All right. So we'll go to our register detail screen. And let's go ahead and make this text a little bit better here. So we'll concatenate on maybe a space and say register detail, something like that. So it would be whatever the register name is, followed by register detail. Now I'm also going to go ahead and throw my name of my register into a variable, because we're going to need to use that in a couple of places. So we'll start off by saying string register name is equal to that guy. And then we'll concatenate register name. Actually, I want to see something here real quick. We have a version of the string constructor that takes a format. Nope. There is a version of, there's a system that out.printf that gives you, it lets you do a formatted string. I was seeing if I could build a formatted string here. There might be something like string buffer or something like that that lets you do it. That way I didn't have to do the crazy concatenation stuff here. I could have just built the string with a placeholder %s like we do in C++. All right, so we'll set the text to our thing there. Now we want to go ahead and give ourselves access to the register. We'll just do everything as local variables here, and then we'll make them more global as we might need them. So I'm going to go ahead and I'm going to say register, the register is equal to, go ahead.
So string.format can be used
as a straight, so it's a class.
Yeah.
String.format. Okay, perfect. Thank you. So %s register detail, and then my s will be register name. And here, just real quick, I'll show that real quick. So this allows you to format a string using old C style placeholders, so your concatenation stuff isn't so messy. So I'm saying %s, which is a placeholder for a string, followed by a space, followed by all this text. And then this variable right here will replace this s. If we want to put another thing here, like a %d for an integer, we can put another value here, like a 5. And that 5 will fill in for the d, the register name will fill in for the s, and so on and so forth. So that makes concatenation a little nicer. Let's test this real quick and make sure that he didn't lead us astray, but it makes sense to me. I think it'll work. X0 register detail. All right, and of course we've tested it for every single one of them, so it works. Okay, so now we're going to go ahead and give ourselves access to the actual register object that happens to have the name stored inside of register name. So I'm going to create a variable register the register, and I'll set this guy equal to, now remember we put a power tool inside of AR map that we used for the last assignment. Say AR map dot find register with name. I'll give this guy the register name, and this will go and return for me the actual register associated with that guy. Okay. All right. So now what I'm going to do is let's go back to our register detail screen, and let's put a couple of more, text views in here. One for the current decimal value, and then maybe one for the binary value, something like that. So I'll take I'll take a text view. We'll drop this guy in here, and we will set his gravity to center horizontally. I don't know. Yeah, I like that better anyways. All right, and then I'm going to set its text to be decimal value. All right, and we'll keep it small like that. What do we got in text appearance? Anything fun? Oh, text color. I like color. So you go to color, drawable. Do I usually have more color? Oh, Android. Here we go. Color. Android. Ha ha. Light blue color. Very hard to read. All right. Dark red color. Bold. Italic. Bigger. Ha, perfect. All right. Now you know why at all church picnics my wife just puts me out on the lawn with crayons.
You didn't even name it.
Huh?
You didn't even name it.
I don't need to name that one yet. That's just a label. My next one's going to be the guy I name. Yeah, so yeah, this is just me saying that the guy underneath this is the decimal value.
It's not done yet. It needs an underline, a shadow.
It's fine. It's perfectly fine as is. All right, so now I'll throw another text view in here. We'll set this guy's gravity to center horizontal as well. And I'll just put like a placeholder value in here, like a 5. All right, but we will name this guy decimal value TV. All right, and we can bold that guy. We can make it a little bit bigger, maybe. Okay. All right, so now what we want to do is we want to connect this guy up in code and set this text view equal to the value of that register, proving that we were able to get it over there and proving our lookup worked. All right, so here's our detail screen. We're going to go ahead and give ourselves access to that text view. I'll create a variable up here. So I'll say comma. What's that guy called? Decimal value TV. And then down here, I'm just going to put those guys all together. This dot decimal value TV is equal to the text view version of this dot find view by ID r dot iv blah blah decimal value TV, like that. All right. So then I will set my text. Then I'll get my register, and then I will set the value of that guy. This dot decimal value TV dot set text equal to the register dot get value. And that's going to come out as an int, right? Just get value. Is that a string or an int? It's an int. Oh, so this will be interesting. So I'm going to set the text to this guy, and this should not give us what I think it's what you might think it's going to give us. Let me make sure that's the case first, and then I'll show you why. All right, so I'll go ahead and I'll give a 7 here in X2. I'll save that. Go back to registers. I'll click on X2. All right, so app crashed. Now, the app crashed because of this line right here. And the version of set text, so this guy is an int, right? So there's a version of set text that takes a resource ID. So what it just looked for is it was trying to look for a widget with the name that was mapped to number 7. All right, and if I do something like r.id. Capital R. So here, let's just do decimal value TV. So here's the value of that guy, 7F070033. Not even close to a 7, right? So it seems like they're pretty big numbers that are mapping to our widgets on our screen. All right, this is just Android's internal way of keeping track of when you drop a text view in there and you name it something memorable. Android's actually storing it as some unique ID number, like a social security number type thing. But rather than us having to memorize that, we could just reference it by saying r.id. whatever. All right, so now the reality is what it's expecting here is not so much an ID, but it's an r. You could use attribute, but there's a string. Yeah. So you can have something stored in your string file. That might be the name of something. So like there's a couple of things that are already in there. App name. So I can set the app name there, and that will map to something real. All right, but that's not what we actually want to have in there. We actually want to have a string. So I'll say empty string concatenated with the register.getValue. We want the actual value that's stored in that register, proving it was able to get over to that side. All right, so I'll put my 7 in there. I can't, if I just click it now, that 7 hasn't actually been saved in my register, so it's going to still be a 0. So if I do that, it's still a 0. If I go back, then I hit save, then I come back in here, click on that, now it's a 7. Okay, so we are getting the correct name over there. We're using the name to look up that register. Now we have our actual register object. Now let's go and look at what our register object currently does for us. All right, so we have the name. Here's our decimal register value. So that's the, this is the human readable name. That would be like X0, X1, X2. The decimal register number will get us the 0, the 1, the 2 from it. Then we get the 5-bit binary register number from that 0, 1, 2. Why do we need that? What's the purpose of this guy? The 5-bit value of this register. Somebody who hasn't answered yet today. Why did we write this? We like looking at registers as humans. We like a register that looks like X0 or X1 or X3. That's complicated enough for us, right? But the reality is that register X3 is actually the 3rd register. So we extract a 3 from it. But then we're going to store that 3 as a 5-bit value. Why?
That's what the machine is.
Okay, tell me more. The machine does understand binary, that's true, but why specifically 5 bits?
The 5-bit is basically 32-bit and is divided by 5, 6-bit, and 11-bit for a certain value, and we set 5-bit for the register name.
Okay, so this goes back to in the book where we say how is a machine instruction shown, and we have our instruction name as 11 bits, and then the actual registers are stored as 5-bit inputs. Now, why did they pick 5 bits?
Sufficient enough for 5 bits.
What's the biggest decimal value that you can store in 5 bits? 5 ones, right? So that is 1, 2, 3, 4, 5. This is the ones place, the 2s, the 4s, the 8s, the 16. So 16 plus 8 plus 4 plus 2 plus 1 is 31. Is that right? So 0 to 31 can be stored in there. Okay. So does that happen to match up exactly to the number of registers we have? Yep. So we need all 5 of those bits to be able to hold the numeric version of all of our registers. That's why registers are 5 bits big. Okay. So that is the 5-bit register number. This is the decimal value. Well, we started off at 0, but when we set the value, it gets set to the decimal value of that guy. Now, should I be able to get the binary value of a decimal value? I mean, that's actually how registers are stored, right? Okay, so I can either store it that way, or so when I set the value, I can go ahead and get the decimal value of it. So I'm going to go ahead and write a couple of functions in here. Let me just make sure I didn't write anything that would be helpful in AR map. Find register, lookup instruction, decimal to 5-bit binary. Yeah, I think we should do this local to the register. I think it'll make some sense for us. Okay, so I'm going to create a private function in here. This is something that we're not necessarily going to access externally. If at a later point in data decide it might be handy to access it externally, we'll do that. But for right now, let's just make it private. And I'm going to make this guy, he's going to return a string for me. Now I'm actually going to make him static. This would be a good example to show you why you might have static functions in the same class as non-static. So I'll say private static string, and we'll call this guy to binary string. All right, and this guy will take an int value as a parameter. All right, so for a moment, forget about where this guy lives. Forget about that he's static. Forget about that he's inside register, whatever. We're writing this function right here. And the purpose of this function is to turn this integer value into a binary string. Now, how big are our registers in our ARM world thing? Are they 16-bit or are they 32-bit? In the actual ARM architecture, you actually have 8, 16, 32, and 64-bit registers. All right, so for us, why don't we just assume that a register is 32 bits? And just to protect us a little bit, why don't we go ahead and just create a private int bit size. I'm going to actually make this a private static int. Yeah, let's do that. I don't want to do that. I want to keep it as non-static. And we'll set bit size to, what did I say, 32 or 16? 32? Okay. All right, so 32-bit is my bit size. So whenever I need to know the bit size of a register, it'll be stored in there. I could argue that there could be another constructor here that allows me to create a register of a different bit size, where I say this guy is actually going to be a 16-bit register, and he would then update this guy with a 16. But for us right now, we'll just leave it. We'll let this guy remember what his bit size is, so that in the future, if we want to change it, we can just change that one number there, and all registers would just update. Okay, and I'm not going to use bit size in here since we're not actually storing binary numbers, at least not yet. But in here, when I get a integer value, I want to convert it to the binary equivalent of that value in bit size number of bits. That's what I ultimately want to accomplish. Make sense? All right, so how do I convert a binary value to or a decimal value to a binary value?
You have that function on.
Okay, so an AR map. So we have decimal to 11. Oh, decimal to n-bit binary number. Perfect. Good thinking, Charlie. So we're going to give this guy a number. We're going to give this guy a number of bits. So we're going to give it bit size. And he's going to spit back for us that value as a binary number, right, of the correct size, because we already wrote this. Perfect. Now, we probably need to loosen the reins a little bit on this guy since he's currently private. I'm not going to be able to access it from over there. So if I just go ahead and if I remove static from it, it now is package level security. You just want to throw public in front. It's probably fine. So we'll say decimal to n-bit binary. This will be a handy function for us to use. So we're going to use this from over here in register. So we'll say string bin is equal to armap.decimal to n-bit binary. We're going to pass it value, and then we'll also pass it this dot, actually not this dot bit size. We'll pass it, it's actually a better reason to make this static for now. I'm going to make that bit size static for right now, just to make this part a little easier. All right, so I'll say bit size. Okay. So this will go ahead and it will convert this decimal number to an n-bit binary. How many bits? Bit size number of bits. We're currently in a static context. So this guy actually is like putting register dot bit size in front of it, because this is a static variable. How do we call static fields? We say register. We say the name of the class dot the name of the field. Okay, but since we were in a static context, the register dot was not necessary. But I like putting it in there, so we're going to leave it there. All right, so this guy is going to produce for me a string of this size equal to this value. Now things are a little bit sketch right now. What's the possible problem with what I'm doing right this moment? This guy will work roughly half the time. When won't it work? Good. Negative number. Okay. Well, so my decimal to n-bit binary doesn't work for negative numbers right now. In fact, it might even just croak out, right? Because I'm going to start dividing. Actually, I'll probably get numbers, but it's going to give me very weird values. All right. So I need to ask the question first. I need to ask the question. I need to say if value is less than 0. So if it's a negative number, I'm going to do something. Else, I'm going to do something else. So if it was a positive number, I'm good to go ahead and do this. And I can actually just return that value if I'd like. Because if it's a positive number, converting it to a bit size binary version of itself should be sufficient. But if it's a negative number, what do I need to do? What do we do with negative numbers?
The encoded to 2 complement.
Encoded to 2's complement. So the first thing I'm going to do is I'm going to make this guy, well, I'm making him a positive number so I can get my binary string. So I'm going to go ahead and call my value times -1 along with bit size. So I'll swing it around to be a positive number now so I can get the correct binary value, right? Okay, then what do we do? Now we have a binary value. How do we convert a binary value to its 2's complement form? Flip the bits, add 1. All right, and I think we've written that before, right? Okay, is it in this project or is it in another project? It's in this project. Where we put it? Binary value?
Oh, actually, it's in.
Oh, other project. Oh, we'll just write it again then. Just write it again. So we're going to go ahead and flip all the bits. Good news is I already have something that's the right size. So I'm going to create a I'm actually going to give myself a private function here. Static string flip bits. This guy will take a string bin as a parameter, and his job is to go ahead and build another string that is the inverse of the current string. Okay, so what we'll say is we're going to say string answer is equal to the empty string. For int I is equal to 0, I is less than bin.length, I plus plus. So we're going to be building up something in answer. So we'll say answer plus equals, and now it's either going to be a 0 or a 1, right? So we're going to ask the question, if bin.charat I is currently equal to a 0, then boil down to a 1, else boil down to a 0. Return answer. So another fun use of an inline if statement. All right, so I'm going to go through every bucket of bin. Each time through, I'm going to concatenate something onto answer. What am I concatenating? Well, I'm going to ask a question. If the current character I'm looking at is a 0, if that's true, concatenate on a 1. Otherwise, concatenate on a 0. Make sense? All right, so this will go ahead and, so I'll go ahead and flip the bits. So in here, I'll say string flipped is equal to register.flipBits, passing it bin. So that'll flip the bits there. All right, then I need to add 1. So how do I add 1? We got to do the whole carry thing. Okay, or we could take the Matty shortcut. Isn't this that's what you want, is the Matty shortcut? For
What is it?
yeah, well, you know what it is. You did it, right? Do we want to take the Matty shortcut, or do we want to write the carry? Good choice. We did already write the carry though, but we'll still do it again. All right, so what we're going to do, for the sake of time, we'll do the Matty shortcut. We'll do a little cheat. Just
Using resources.
huh?
Using resources.
No, I'm okay with that. In this context, that way people can see both. So we understand we're supposed to flip the bits and then add 1 to it, doing binary math, right? Okay, so what we're going to do here is we flipped the bits already. Now we're going to turn that into a decimal number, add 1 to it, then turn it back into a binary number. All right, so I'm going to go ahead and get the decimal number of flipped. Now, if we're going to use our resources fully, we'll go ahead and say integer.parseInt. I'll pass this guy flipped and let them know that it's currently in base 2. All right, so that's going to give me my decimal version of this. I will add 1 to that, and then I want to convert that back to binary. So encoded is AR dot decimal to n-bit binary. The value we're going to pass it is that value, and registered dot bit size is our number of bits. So this guy right here will convert our current flipped bits to a decimal, given that it's currently in base 2. We might have already had that value. Did we do that in binary value too? Well, it doesn't matter. This is a fun enough way of doing it. So there exists a version of parseInt that allows you to pass it a string as well as the base that that string is currently in. And then it will spit out for you the decimal version of that. What am I doing with that decimal version? I'm adding 1 to it. Then what am I doing? I'm calling my decimal to n-bit binary from ARMap with that new decimal value as well as the number of bits I want it to be. And this should then be my encoded value, which I can then return as encoded. Make sense? All right, so that's going to be my 2 binary string. Okay, so now I'm going to go ahead and add to my thing up here. To my thing here. What was the name of that function? 2 binary string. Okay. So then I'm going to go into my detail screen. I'm going to steal this text view because it has, drop it to the bottom. I'm going to change this to say binary value. All right, then I will copy this guy, and we'll call this guy binary value TV. And we'll just put some binary number stuff in there for right now so we kind of flag our mind knowing this is for storing a binary value. Okay. And then what we'll go ahead and do is we're going to hook this up and set it equal to the binary equivalent of our register. So that's going to be in here. I'll go ahead and give myself that binary value TV. This dot binary value TV is equal to the text view version of this dot find view by ID r dot ID dot binary value TV. And then we'll say this dot binary value TV dot set text equal to the register dot, what did I call that guy? Okay, I made it static. So this is a 2 binary string. So since it's static, it's a class method. I call it with the name of the class. So I'll call this guy with register dot register. Oh, thank you. Oop. Register dot 2 binary string, passing it a value. What value? The register dot get value. All All right, and that should set the text. All right, so we'll go into our registers. I'm going to say x0 is going to be 14, and we'll say x1 is -8. We'll go ahead and save those guys. Go back into registers. So the binary version of this guy should be a 32-bit number that starts with a 0. So there's 32 bits that starts with a 0. If I go back, this guy should be a 32-bit value that starts with a 1. Ruh-roh. Where did you die? Let me just confirm it's with that, the Maddie hack line. This is what you get for cheating. All right, so currently nothing. Good. So it is this encoded line. All right, so integer.parseInt flipped should be a bunch of binary numbers. Here, I'm just going to return flipped here. Let's just see what that guy looks like, since we have a couple of minutes. All right, so that's it flipped. Looks reasonable enough. Yep, so that should be an 8, right? 1s, 2s, 4s, 8s. So we have a single 0 in the 8 spot. That looks correct. All right, so integer.parseInt flipped. And telling that's in base 2, that should be fine. Let's just see what that gives me. So this should be a giant number. Oh, is it not like the... So does this guy not do what I thought it did? Integer.parseInt. This will be 24, 27. So if this works the way I think it should work, this should give me a 27. Oh, this converts it to that. So if I give it this number and I say I want it in base 2, is that too big of a... Isn't that how parseInt's supposed to work? You're telling it what radix the value currently is in. Maybe it doesn't, well, no.
Yeah, it should take the...
Oh, hold on. It's still the wrong thing here. And actually this n-bit binary value, that looked kind of weird too, but I need to make it a negative value to really test this. -8, save it. Otherwise, it won't get into that part of the if. Yeah, that's the 27. So it does what I thought it should do. So then why wouldn't flipped in here work? That's just a big old binary number. Does it not handle one that is that large? Well, I'll patch this up at the end of next time. So homework for Thursday is to make sure, if you were not there, to watch the machine learning video for the hackathon on Saturday morning. So the video is on Slack. It's under ML Bootcamp or something like that. So the first, it's like an hour and a half or so long video that takes you through what is machine learning, what's TensorFlow, how does it work at the high level. Then I give instructions for installing it on your Windows machine, or you could follow, it's the same instructions for installing it on a Mac as well. All right, I will see everybody on Thursday. Remember, tonight is the blockchain talk at 7 p.m. in the Fishbowl. Strongly encourage you to attend.
Next exam, I believe that's the Wednesday before next year. Yeah, next Wednesday.